Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to get our last section in Chapter 4.8, and we're going to be exploring how to solve quadratic functions by first setting them equal to 0 and solving. We might have to do some factoring when we set it, so we're going to set equal to 0, factor, and then solve. And then we're also going to look at some story problems, some word problems, applications of this as well. So again, it's called the principle of zero products. If you have any one of these values, so if you have x plus 3 times 0, the whole thing will go 0. And likewise, if you had x minus 4, if any of these values equal 0, the whole thing will be 0. So that's what we're going to try to do. Put things in standard form, which is this ax squared plus bx plus c. If it's in this standard form, we'll set it equal to 0. We'll try to factor this thing, and then we're going to set each factor equal to 0. So I'll set my a term equal to 0, and I'll set my b term equal to 0. Because if either a or b is 0, the whole thing will go to 0. So let me give you an example. If I set this equal to 0 by subtracting off 8 from both sides, try to find factors of 8 that differ by 2. We're going to use 4 and 2. Signs are different. The larger term is negative, so m minus and m plus. M could equal 4, because that will set this equal to 0, and 0 times m plus 2 is 0, or m could equal negative 2. And those are going to be my two solutions. You can put this in solution set form, practice drawing those little squigglies. Oops, looks like I'm pretty bad at the squigglies too. Solution set notation. So obtain of 0 on one side, factor it, and then set each factor equal to 0. And then we're going to set each factor equal to 0. So let's try it again. I'm going to put the highest degree term first. So 4y squared plus 11y minus 3, if I put these in descending order. Now I need to find factors of 4 and 3 that differ by 11. Now, if you haven't seen my factoring techniques and you don't know what I'm doing here, I would recommend that you watch a previous video here. So here's the first term, here's the last terms. I'm really just doing the FOIL method, looking for things that differ by 11. So I need big numbers, like 4 times 3 is 12, forcing 1 and 1 together. And those red numbers, 12 and 1, differ by 11. So my first terms that I'm going to choose, I'm not going to use the 2 and the 2, I'm going to use the 1 and the 4, so I'll say 1y and 4y. And then probably the most important thing that I could emphasize is drawing this yellow brick road, because it emphasizes outer terms, and that's what comes after first terms. Don't try to plug in the last terms. Let's plug in these outer terms, which is 1 and, looks like 1, go together. So I'm going to put 1 and 1 for my outer terms. My inner terms are going to be 4 and this guy right here. 4 and 3. Signs are going to be different. The larger term is positive, and that means 12 is positive because it's larger than the 1. And then I set each term equal to 0. So y plus 3 equals 0 when y equals negative 3, or 4y minus 1 equals 0 when 4y is 1 or y is 1/4. So my two solutions would be negative 3 and 1/4. Here's how the author chose to work it out. Let's try this again. This is a little bit easier to factor, but it's kind of an interesting solution. Factors of 16 that add up to 8 are going to be 4 and 4. Signs are alike. They're both negative. And so look at this. You could write this as x minus 4 quantity squared. You could take the square root of both sides, giving you just x minus. So notice you just have one solution. And that means that this is a parabola. It must be coming down and just bouncing off right here at 4. It's called a double root. So it's not passing, but it's bouncing, and that must be the vertex as well, 4, 0. So there's only one solution. This problem says let f at a equal 1. And well, we don't really have an f at a. We have an f at x, but we can find f at a by every time you see an x, plug in an a. So this becomes a squared plus 10a plus 26. Now I can let f at a equal 1. Remember, f of x is equal to the y value. So that's just like saying y, which the y value now is 1. So 1 is equal to a squared plus 10a plus 26. So remember, if f at a is y, or f at x is y, f at a is also a y value. It's just evaluated at a. So I'm going to set this equal to 0 just like we did all the other functions. Try to, oops, that's a 5 if I subtract off 1 from both sides. Factors of 25 that add up to 10 are 5 and 5. Signs are alike. They're both positive. And once again, if I set these equal to 0, I get x plus 5 equals 0 when x is negative 5. And the same thing over here. Oops, but I don't have an x, so sorry. I should have said A. Those are all a's. And so a, it says find a, and I think I found it. A is negative 5. So the whole problem should have been worked in terms of a instead of in terms of x. This one says find the domain, and I have problems with functions when I divide by 0 or take the square root of a negative. So those are the two things we want to watch out for. If you divide by 0, that causes undefined, and if you take the square roots of negatives, that causes undefined. So I really want to know, when does 5x minus 10x squared equal 0? Because when it does, then I'm dividing by 0, and that's not part of the domain. The domain has to be all reals. So I'm going to add 10x squared to both sides. So no, let's factor out a 5x instead, because it's already set equal to 0. So factoring out a 5x literally means I'm going to divide each term by 5x. You don't need to write the red step, but that's kind of what I'm thinking, is divide each term by 5x. And I'm left with 1 minus 2x. So now I'm going to set this term 5x equal to 0, and I'm going to set the 1 minus 2x. So every factor gets set equal to 0, and 5x really is a 0, or a factor. So if I divide through by 5, I get x equals 0. And let's add 2x to both sides. 1 equals 2x, or 1/2 is x. So what does this mean? These are really not solutions. These two things is what causes the denominator to go equal to 0. And of course, I have problems. If I let x be 0, this is 0 minus 0, and you can't take 3x and divide by 0 because that's undefined. So really, the domain is all reals. Everything works. It's just x cannot be 0 and 1/2, because those are the two things that causes the denominator to go to 0. So I would say the domain is all values of x such that x is a real number, but you just can't let x be 0, and you can't let x be 1/2. Another way to write the solution would be negative infinity all the way up to 0, 0 to 1/2, and then 1/2 to positive infinity. So that's called the interval notation. So however you display that to me is fine. So remember, a squared plus b squared equals c squared is a nice geometry theorem that we've proved. So let's see if we can use that to find some lengths of the diagonals here. So I know that this side and this side are my legs, and those sides, those green sides squared, should equal the red side squared. So I'll write it out, a squared plus b squared being the two legs. So if I have a triangle here where this is a and this is b, that should equal c squared. So I'll say x plus 3 quantity squared plus x squared should equal x plus 6 quantity squared. Now don't get tempted here to distribute. We can't distribute this, and we'll end up with wrong answers if you try. This literally means x plus 3 times x plus 3. So you really should FOIL this out. So it's squaring the first. Its outer terms is 3x, inner terms is 3x for 6x. And notice there's a rule here. Square the first twice the product, square the last. Let's do it again. Square the first term twice the product. Well, the product of x and 6 is 6x, but you double it. So the rule is square the first twice the product, square the last. Then I'm going to try to set it equal to 0. Well, let's see. Over here, I've got 2x. Well, I'll write it out. 2x squared plus 6x plus 9 equals x squared plus 12x plus 36. So if I subtract off x squared, I'm left with just 1x squared. Let's subtract off 12x's while we're putting everything over here. I've got a negative 6x, and let's also subtract off a 36. So I can set it equal to 0. 9 minus 36 is 27. And then I'm going to try to find factors of 27 that differ by 6. If I can't find factors of 27 that differ by 26, I would have to use the quadratic formula. But I think I have them. 9 times 3 is 27, and they differ by 6. Signs are going to be different. The larger term is negative. And so x could equal 9. If I set that equal to 0, x could equal negative 3. But wait a minute, we're talking about sides here. And it doesn't make sense for this side to be negative 3. So I think I'm going to throw out the negative 3. And I'm going to say x could be 9, and then x plus 3, 9 plus 3, could be 12. And then x plus 6 would be the 15. So I would say the three sides are 9, 12, and 15. Let's see what the author says here. So it looks like the author had the same solutions, 9 and negative 3. And again, they throw out the negative 3. It can't be the length of a side. And so the length of the diagonal, which is what they asked for, must be the 15, which we found as well. Again, finding the domain, we want to look at when does the denominator equal 0, because that's what I want to exclude. So factors of 15 that differ by 2 are 5 and 3. Signs are different. The larger term is positive. So negative 5 and 3. So I would say all reals, x cannot be negative 5 and 3. There's several ways to write that solution. X such that x is a real number, but it just can't be here, or you could do interval notation. Negative infinity to negative 5. Negative 5 up to 3, exclude the 3, and then 3 to infinity. So those parentheses excludes those values. I'm going to show you a little bit about how to graph these on your graphing calculators as well. Solving quadratics on your calculator is as easy as graphing them, just simply looking where the function crosses the x-axis. So we're going to guess to the left, put a little arrow there, guess to the right, put a little arrow there, and then guess on. Some of you have done this before, some of you have not. Instead of a second way of finding a solution is not by setting it equal to 0, but you could just let y sub 1 be maybe the parabola, and then y sub 2 be a separate function, and then go find the intersect. So there's a couple different ways that you could do this. I'll show you both methods. How about it? So first of all, I want to know, I've got a formula of a ball going up into the air and coming back down. After peaking, the t-shirt's going to come down and a fan is going to catch it. So it looks like someone's shooting a t-shirt up in the air, and the fan is going to catch it at right here, maybe at 70 feet. So maybe hopefully the t-shirt goes above 70 and comes back down. But it looks like there might be two solutions of where it's 70. Let's go find out. So let's go find out where the height is 70 by setting 70 equal to this. And let's go ahead and set it equal to 0. Since I have a negative 15t squared, I'm actually going to choose to throw everything over on the left side. So I'll have a positive 15t squared. I'm going to keep negative 75t if I subtract that off. And then I'm going to subtract off 10 and get positive 60. Looks like I can factor out a 15 from this as well. And that'll give me t squared minus 5t plus 4. If I divide through by 15, I'm just left with t squared minus 5t plus 4. Factors of 4 that add up to 5 are 4 and 1. Signs are alike. They're both negative. So t minus, t minus. So there's my 2 points. After 4 seconds, I'm here at this point. And after 1 second, I'm also at a height of 70 because it's going up, hits 70, goes over, and then, so here's 1 second, and here is 4 seconds. But it says after peaking, so I think the answer would be 4 seconds. So again, should be able to graph this in your calculator by maybe letting this be your y sub 1 function and letting this be your y sub 2 function. Or another way to do this would be just go into your y sub 1 and set it equal to 0 by graphing negative 15t squared plus 75t minus 60 if you just subtract off 70 from both sides. It's okay to type in y sub 1 to be negative 15t squared plus 75t plus 10 minus 70. Your calculator will swallow that up. If you don't want to calculate the negative 60, it's the same thing. So we'll look at a calculator here in a moment. There's a lot of ways that I could show you how to do this. Should we try the y sub 1, y sub 2 method? Negative 15x squared plus 75x plus 10, and I let the y sub 2 be the second function, 70. So this time I'm not going to guess left, guess right, guess on to find the zeros, but I'm going to go find the intersect. I'm going to hit zoom 6. That gives me a standard 10 by 10 by 10 graph, so no matter what I did on the previous problem, I know I can always start with a 10 by 10. It looks like I need to see up a little bit higher, so I know I'm thinking that the ball is at least going to go up to 70. So I'm going to change under my window, I'm going to change my Y max to maybe 100, so I can see well beyond. So I'm going to hit trace. Still didn't catch it. But what I'm really interested in is where that red line hits that blue line, because that's going to be my 70. So I don't need to see the vertex of the blue parabola. So if I was going for the zeros, I'd hit number 2. But if I'm going for the intersect, I would choose number 5. And you just hit the white key 5. It's faster. And it's saying first curve. Well, I'm going to make sure that, see how this little spider bug is on the blue? So I'm going to identify that as my first curve, is the blue curve. And then when I press enter, it jumps to the red. And you can go anywhere along on that red you want. You just have to identify. Sometimes we have 3 or 4 functions here. This one's kind of easy because I just have a blue and a red function. So I'm going to press enter on the red, and then it says guess. And the reason why I need to guess is because there's 2 places that these intersect. So I'm going to guess right here, and it gives me the 1, 70, and then I repeat the process. Second, calculate 5, identify the first function. That's the blue function. Identify the second by pressing enter, but this time I'm going to come over here and guess over on this side, and that gives me the 4. So you could do this on your calculator, but I hope you can do it algebraically as well. This video is getting a little bit long, so I'm just going to set up these last couple problems and leave you to solve them. We have a house, and it says that it's they're going to put a stake. We'll put the stake out here, and it's going to form a right triangle. So let's put the right triangle here at a right angle to the house, and then let's go some distance away from the house. So here's a right triangle, and we've got 3 consecutive integers. So 3 consecutive integers would be like x, x plus 1, and x plus 2. You just got to make sure that this side, which is the hypotenuse, is the longest leg. It wouldn't make sense if it wasn't. So I've got my triangle, and I would say what? A squared plus b squared is equal to c squared. And then I would go ahead and multiply that out and solve for x. And I'll let you see how the author did it here. Again, it doesn't make sense to be -1, so we throw that out. So if x is 3, then we go back and answer the question. Probably a 3, 4, 5 for my x. So that this is a 3, this is a 4, and then 3 plus 2 is my 5. So those would be my 3 answers. The last example talks about a ladder up against a wall, and the height reaches a wall with a length that's consecutive integers. So this could be my x side, this could be my x plus 1, and again I would say x plus x squared plus 9 squared is equal to x plus 1 quantity squared. Remember, you got to make that hypotenuse all by itself. So it's got to be the first leg squared plus the second leg squared, and that's my blacks. Oh, this one's a little bit easier to do. X squared plus 81 is equal to x squared plus 2x plus 1. Again, I would set this equal to 0. That looks pretty easy to do, actually, because the x squared terms cancel out if you subtract those off. And if I subtract off 1 from both sides, I get 80 is 2x, therefore x is 40. So this must be a 40, and this must be a 41. You could check it by seeing if 9 squared plus 40 squared was the same thing as 41 squared. And I think that does check. So we've solved it. I hope you found this video helpful. Email me with your questions. Thanks.